Hello, guys. Hope you are doing well and staying safe. So, let's start today's session. So, we are going to discuss a problem today. You are given an array of non negative elements in which all element appears thrice except one element which appears once, and you have to find the element that appears once. So, is the question clear? Let's understand it better with an example. So you are given the array 3 1 6 2 1 3 3 2 2 1. Here you can see that 3 appears thrice, 1 appears thrice, 2 appears thrice, but 6 appears just once in this array. So the answer is 6. Can you suggest me some approaches? You can write in chat section. Yes, Anurag, it's a good approach that Anurag has suggested. So what Anurag has suggested is that for each element, let's check in the array that if that element occurs just once or thrice. Like for 3, we will check in that array. So wait just. So in this array, 3 appears thrice, 1 appears thrice, 2 appears thrice, and 6 appears once. So 6 was the answer. So let's see this with Anurag's approach. So for 3, we will check the complete array. 3 appears thrice. Now for 1, we will check the complete array and we will see that 1 appears thrice. Now we will check 6 within the array and we will see that 6 occurs just once. So 6 is our answer. So we can return here the answer. So is this approach clear to everyone? Yeah, very good. Very good. Cool. So can you suggest me the time complexity for this approach? Yes, right. You guys are doing well. So time complexity as suggested by you guys are n square. And why it is n square? So this is big of n square, and this is n square because for each element we are checking the complete array. So for n elements we will check complete array. So this becomes n into n. Like for first element you will check the complete array. Again for second element you will check the complete array. Again for third element you will check complete array, and so on this goes. So this becomes n into n. This is nothing but equal to n square. Okay, good. So now can you suggest me the space complexity? Yeah, space complexity is big of 1. Why? So because we are not using any extra space. So that's why the space complexity is big of 1, or we can say that it takes no space or constant space. Yes. So this was a brute force approach, and which was suggested by Anurag. Can you optimize it in terms of time complexity? Like let's suppose you are given the number of elements you are given is approximately roughly equal to, let's say, 10 to the power 5, because n square will fail here, right? Because yeah. So yes, Deepak has suggested a very beautiful approach to solve this problem in better time complexity. So Deepak has suggested that let's take a hash map and map the every element with the frequency by which it occurs in the array. Like when we will use the hash maps to map the frequency. Yeah, hash maps. Yeah, so 3 appears how many times? 3. 1 appears how many times? 3. 6 appears how many times? 1. And 2 appears how many times? 3. So you can see that here we can directly check this complete array and we can make the hash map that or we can say that frequency table in hash maps, and there we will find that 6 appears just once. So this is our answer. So what is the time complexity for this? So yes, very good again. Yes, so the time complexity is big of n. And why it is so? Because for each element you just need to put element in hash maps. And what is the time complexity to put an element in hash map? Yeah, O of 1. So O of 1 into n times big O of n. Yes. And what is space complexity? Yeah, very good. Space complexity is big O of n. Why it is so? Because we are taking extra space to make a hash map, and that contains data of n numbers. Yeah, n by 3, but when while computing time complexity we ignored the constants, so that's why time complexity is big O of n. So we have reached a very optimal solution in terms of time complexity, that is big O of n. Yeah, but can you optimize it in terms of space also? Any approaches for that? If you want hint, then it's a the hint can be that try to use in terms of bits representation of this array, elements of this array. I will copy paste this again so you will it will be better visible. Yeah. Yes, Shubham, exactly. Yeah, Shubham has suggested that the all the numbers are if all the numbers are 32-bit numbers, then we can take an array of size 32 as suggested, and then integer array of size 32, and make then we will compute the binary we will take the binary representation of each element, and according to that we will increase the number in array, and when at the end, after computing this for complete array, we will again check this array, and in this array, if we see that the number of set bits at that location is not a multiple of 3, that means it is a part of the number which appears just once. So that represents that this is a part of answer. Yeah, so let's see. We are going to do this now. So 3 is represented in terms of bit as 0, 1, 1. And how 1 is represented? 0, 0, 1. How 6 is represented? 1, 0, 1, 1, 0. And how 2 is represented? 0, 1, 0. So is it correct? 3, 0, 1, 1, 1, 0, 0, 1, 6, 1, 1, 0, 2, 0, 1, 0. Perfect. So now let's suppose that if this is the number, then uh, now initialize the array. Let's suppose that your array is a, and the size of array is, let's say, 32. Now first we will initialize this as all the elements being 0. So initialize it as all elements 0. Yeah, very good. So it's good to see that you guys are understanding this very quickly, and if not, then I will explain it again. So now let's count the set bits. So for this position, how many set bits are there? You can see there is one set bit. Now for this location, how many set bits are there? We can see there are, okay, so 3, 1, 6, 2. Now 1 comes here, so 1 will again, so I will copy paste this to save time. 1, now 3, 3, so 3 comes again twice. Now 2 and 2, so 2 comes here, and then a 1, so 1 comes here. Yeah, so is it visible to you? So let's count the number of set bits. at this position, how many set bits are there? Total of 1. And at this position, how many set bits are there? 1, 2, 3, 4, 5, 6, 7. So there are 7. And how many are at zeroth position? 1, 2, 3, 4, 5, and 6. 6 are there. So this is the least significant bit, 6. So that means this bit represents 2 to the power 0. So is 2 raised to the power 0 a part of answer? No, right? Because 6 is a multiple of 3. So this is not a part of answer. Now 2 to the power 1 is a part of answer. Yeah, 7. So 7 is not a multiple of 3. So yeah, this one is the part of answer. So that means yes. Now 2 to the power 2, is this a part of answer? Yeah, guys, absolutely. Because 1 is not divisible by 3. So this is a part of answer. Yes. So what is our answer? Final answer? Yeah, guys, absolutely right. So this is equal to 2 to the power 1 plus 2 to the power 2. And this equals what? 2 plus 4, which equals 6. So this is answer. So any doubts? Yeah, I will discuss time complexity and space complexity for this problem. So first, let me ask you guys, what is the time complexity for this problem? Yes, so time complexity is suggested that we are taking, yes, yes, so time complexity is will be computed as uh, so we are traversing through all the elements of this array, and after traversing all the elements we need to find the set bits for all the numbers. So this will be n log of numbers, range of numbers basically. And what is the space complexity? Space complexity is we are taking a array of size 32, so we can say that big of 32, or better we can say that this is nothing but equal to big of 1. Yeah, so any doubts, or is everything clear to you? Yeah, good, 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 cool. So first we discussed a brute force approach for this problem, in which we were taking every each element and then we were checking in the complete array. And that then we moved to a more optimized approach that was using hash maps, whose time complexity was big of n. We were making actually a frequency table and then checking the frequency table to check the occurrence. And then we moved to the third approach, that was a much better approach, that is using bits, in which we checked the all the position of bits and check that whether the number of set bits at that position is a multiple of 3 or not. And this is the best approach that we have got. So maybe we can optimize it more. So guys, think about this. Let's stop this class here, and if you have any doubts you can directly message me. Yeah, good night. Good.